All right, well, welcome everybody. It says I'm live. If someone could just put in the chat that you're hearing me, then I'll know that it's working okay. All right, perfect. Well, thanks everyone for coming this morning. And what I wanted to do today is put in context this idea of a data or analytics translator in a larger context of how roles and responsibilities are changing within analytics and data science organizations today. And so I'm going to walk you through a variety of points to think about, some different roles that are emerging, and give you some things to take home. So let me just share my screen real quick. All right, everybody should be seeing the screen. I'll just pre-warn you, I'm going to go through my talk while I'm sharing the slides. I can't actually see the chat, so I'll come back to the chat when I'm done if there's any questions. First thing, as we talk about modernizing roles, why do we need to do this? Well, one of the big things that's changed in the last few years has been the amount of complexity in the entire space. I mean, everybody knows this, but I can tell you back even 15 years ago, there were relatively few types of data compared to today, relatively few tools to work with that data, both from the analytics side and the storage and capture side. And there was, very few platforms. So suddenly we have, within our space alone, we've moved from just SAS and SQL. We have R, we have Python, we have TensorFlow, all sorts of different tool sets. We no longer just have on-premise platforms. We have cloud. We have multiple types of clouds. We have streaming data. The point is that all of this has made things incredibly, incredibly complex. And as hard as it was to try and be a jack of all trades years ago, it's even more difficult today. And we'll talk a little bit about that as we go through. So part of what's been changing is some of the core roles of analytics and data science professionals in the last few years. So just a couple of core themes here before we get into some of the gory specifics is that there's a lot more time today spent on, say, the architecture and the big picture stuff as opposed to technical specifications. And I kind of liken this to if you're building a house. The architect's going to lay out the house, how many rooms there are and so forth. And someone's going to come in and put the nails in the drywall up. But the point is, as we have more and more tool sets that enable us to do things more and more easily, we're able to focus on the big picture and laying it out. We no longer have to go in and custom code every single piece of our process. We can be borrowing prefabricated pieces, much like they do for home building today, so that we're able to really try and architect higher impact solutions rather than just coding our way into a base solution. This also means we're creating more processes. Each individual these days creates more analytical processes than they have in the past. Now that requires management, and some of the roles we're going to talk about today tie into that need for additional management. But unfortunately, what this also means is you'll spend a little less time creating and a little more time managing your processes that you do create. So I remember early in my career, we'd create a process, and it was often for 1 or 2 time use, or if it was used repeatedly, we just have to go out and update it and run it. But it wasn't really ongoing maintenance in the sense that you need it today, because the processes weren't automated. There weren't a lot of changes from run to run. But here you really have to start, even as part of your job, to do that checking. But then also, it's funny how the value prop has changed. Back when I started in my career, 2 of the biggest value propositions I provided was that I understood analytical algorithms. Very few people did back then. And I had access to them and knew how to run them. And in those days, there were very few tools available to run analytics algorithms, and they were very complicated to use. Of course, today that's all changed. Algorithms are available ubiquitously. Even things like Excel have some fairly sophisticated algorithms that you can run. And out on the cloud, you can get access to virtually anything. So just saying I understand algorithms, I know how to run them, is no longer really a value proposition. In addition, it used to be a good value proposition if I had a good feel for which type of model would work best in a given situation. Well, that's no longer a value proposition either, because with automated tool sets like Data Robot and others, you can try out all sorts of algorithms, and it's very fast and cost effective. When I started, it would take a lot of money and time to actually run iterations of even more simplistic models. And so we had to do a really good job up front of guessing which path to go. Well, today, even if I'm 99% sure that your guess is right, it's so trivially cheap to run all the options that we'll go ahead and do it. And so it really has forced a change even in how we position ourselves and where we think that that we're valuable, to be more about the problem solving, to be more about driving some of the automation and the increased business value. And that's going to tie directly to a lot of the roles we're talking about. And so at a high level, the evolution that each of you has to think about for your organization is, how do you evolve an analytics function, much like how the medical field has evolved? And what I mean by that is, if you went back even 100 years, you would have had a small town doctor, and that small town doctor would have treated everything from, cancer to flu to a broken bone. And the state of medicine wasn't nearly as sophisticated as it is today. And so those doctors, while we all would say today, there's no way that doctor could have done all of that well. That's true. And it's certainly true by today's standards. But back then, when there were so few cancer treatments, as an example, that doctor might have been able to approximate the best treatment that was available at the time and could get away with it. Today, of course, we'd only want to go to a doctor that specializes in cancer. This is much like the analytical field. When I started in my career, we were all generalists. We were all the small town doctor. We had to acquire the data. We had to prepare the data. We had to model it. We had to do whatever it took to deploy it and put it out there and present it. And because it was a limited scale of analytics that we needed to do, and they were each very costly, we could just kind of go through that custom process, and we could do a good approximation of what was reasonably possible at that point in time. And most of the algorithms were your classic statistical predictive models, maybe econometric forecasting, et cetera. Well, think about where we've already gotten to today, and we'll talk about this as I go through my talk here. We've got not just data scientists, but we have data scientists who specialize in one type of analysis, like natural language processing or maybe deep learning. We've got people who specialize in certain subsets of those. And that's the same thing as the medical field. I could go to my local medical practice today. They now have big buildings with dozens of types of specialists. And there's not just a cancer specialist, but there's a pediatric cancer specialist, not just a pediatric cancer specialist, but a pediatric brain cancer specialist. The point is, all of these specialties have arisen because the field of medicine has evolved so much that you can actually specialize at that level. And that's where we are today. It's specialization. No one can know how to do all of these things on all of these platforms using all of these types of data equally well. It doesn't mean you wouldn't have the potential and you're not smart enough to figure any given one of those out, but you'll never be able to keep up on all of it. So in order to achieve this, you have to embrace what I call analytic athleticism. And this is based on, if you just went to a playground, doesn't matter which playground, doesn't matter where it is, and you watch some kids play a sport, any sport. You could bring somebody over from overseas who's never seen, let's say, never seen basketball played, and let them watch some kids on a playground court. And without knowing the rules or anything else, they'd be able to tell who's pretty good within about 5 minutes, right? All of us can, because there are people who have a natural ability for athletic activities. And the reality is, if you have a Division I college quality or a pro quality player in a given sport of soccer, baseball, basketball, chances are that person could play really, really well at any of those other sports. Doesn't mean they'll necessarily be Division I or pro, but they're probably going to be able to play them better than the vast majority of people, because there are certain underlying athletic traits that help support all of those different sports. And this is what I mean by analytic athleticism. Really, in my experience, what has made the best analytical and data science professionals I've known stand out, it's their ability to understand the problem in a practical sense, to formulate how to attack that problem with the data and analytical tools available, and then being able to help put together a story to explain what was done. That way of thinking and that way of understanding data, I have found that people tend to have it or don't. If you have it, or if your employees have it, the good news is, if you need somebody to figure out natural language processing for the first time and they're a rock star at another type of analytics, my guess is they're going to be able to figure that new methodology out. Similarly, if you have someone who can code anything you've ever imagined in SAS and you want them to shift to Python, no doubt they'll be able to do that. So keep in mind that even as we talk about all of this evolution, the evolution doesn't imply getting rid of everyone you have and bringing in all of new people. It's about identifying those people who are most adaptable and allowing them that opportunity to adapt. But don't mistake, training's great. This is one thing that drives me absolutely crazy today is this idea that you can go out and take a Coursera course or get this certificate here or, dabble in a online course there, and suddenly you're ready to come and do these sophisticated analytical projects. To me, it's ridiculous. So imagine here, paint. I could go and take some paint classes. I could learn all about the history of art. I could learn about how to mix and match colors. I could learn about different brush strokes. I could learn about different styles of painting. I might even pass an advanced placement exam in painting because I understand the facts of painting. However, even if I can recite you exactly how to do a brush stroke, when to do that brush stroke, what colors to combine, am I going to be able to do it in a real setting and make it really work? Well, I'd say no. With painting, if any of you have seen Bob Ross, anyone of an older generation certainly has, and I understand he's been making a comeback lately. I know he's on Netflix now. This guy's amazing. He sits there and describes every single thing that he's doing as he makes a painting from scratch in a half an hour. And I promise you, if I actually did get the paint and tried to follow along, my painting would look absolutely horrible because it's more than paint by the numbers. There's an experience level and there's an inherent ability he has at doing art. And so I'll warn you all to be very cautious of saying, we're just going to grab anybody off the street who has a certificate and says they can do this thing that we need and assume that they can. It doesn't mean that they're going to be any good at it at all. The only way you know if they're good is to see them actually do it. So what are the fastest growing roles in data science today? I'm going to talk about several. First, data engineers. This is on the front end of the analytic process, the ingestion and preparation of data. Then we have our analytics or data translators. You'll notice I've been saying analytics / data translators. I'm a big fan of the idea that there's multiple labels I've seen for things. I haven't been able to figure out where there's a distinction between what's sometimes called a data translator, what's sometimes called an analytics translator. I think they're doing the same fundamental role, but I'll explain when I see that role. Analytics interface and application developers. We'll talk about operations roles, and then we'll finish up with a concept I call a chief data scientist and how that differs. So let's dive into what each of these are. So first, why is data engineering such a big thing? I think that's actually a pretty logical outcome of where we netted out. So if you go back even into the early 2000s, there were relatively few source systems for what was almost always structured data. So you'd have transactional systems in a retailer or the reservation systems at a hotel or airline. And there were people who specialized in getting the data into those systems and managing them. Then we'd have ETL specialists who use one of a small number of common tools to extract data from the source systems, do some kinds of manipulations and load it into a repository. And in those days, the repositories were almost universally relational databases, of which there were a handful of leaders, and you'd have database administrators that would operate it from there. So you had very few and mature platforms across the spectrum of data, and you had people then that specialized in those, and it worked fine for many, many years. And each of those roles, by the way, still exists today. They don't get as much hype, but they're all out there. But a data engineer suddenly became critical as big data hit. And as you start to have different types of data, massive amounts of data, cloud platforms, having to do things more real time, it requires some additional skills and additional work. And worse yet, there's so many new platforms, a lot of open source tool sets. It's amazing to me how some of these data engineers get their work done. It's almost like a Rube Goldberg contraption they have to put together. They're chaining together various tools, various procedures in ways that maybe no one's ever done that way before. If they have, it's not well documented. So it takes a high level of skill to make this work. And one of the big differences I see from a data engineer, they have to be thinking much more of a big picture than some of the past. If you were a database administrator within one given platform, all you cared about was that world within that platform, and you optimized the heck out of it. Data engineers are actually having to optimize a complicated process across multiple platforms and tools effectively. It's a bigger picture optimization that they have to do. Now, a lot of this is really, really difficult and manual today. There are tools, as with everything, evolving to make some of this easier. And I think within a couple of years, we're going to start to hear the term citizen data engineer like we do with citizen data scientists, where the idea is some people who aren't as deeply skilled and creative as a full-on data engineer can take care of a lot of the basics with some more standardized tools, but time will tell. Then we get into this idea of a translator. I've been a huge fan of this for a while. A couple of thoughts here. First of all, you don't have to necessarily hire literally a data translator out of the gate, meaning a net new headcount to prove it out. I would argue today you certainly have translators. They're doing the translation role. It might be a business person who's fairly analytical. It might be some of your analytical people who are very good at talking to the business, but they're doing it as a role. So differentiate role from full-time position here. But whoever's going to do it has to understand both the business side as well as the analytics and data science side. And one of the huge mistakes I see companies making as they dabble in this is they think of it as kind of a glorified project manager role. And it's not that. You will fail if you just simply take a generic project manager and ask them to do this translation. I actually think this should be one of the more senior roles on the team. I'd like to see a director or VP from the business step into this role, or a director or VP from the analytics and data science team step into this role. These should be highly experienced, very intelligent people who have proven they're able to do this. So as opposed to being a junior project manager, one of the lowest paid people on the team, I think if you're going to do this correctly, you might have some of your very highest paid people on the team serving this role of translator, just based on the level of experience that they need. But they play such a critical part at the beginning and end of this process. And frankly, over the years, without thinking of what we were doing as doing this, this is in fact what those of us who managed to be successful when we didn't have so many resources at our disposal ended up having to do. And I give whole other talks on some of the pain I went through as I learned how to do this. Now, another thing that's really been evolving rapidly is what I call analytics application and interface developers. And this is another translation role of a different angle. This is translating analytical output into interfaces and applications so that end users can make use of it in context of their job and that it looks good. So we get back to, again, could I and have I developed, quote, applications on top of my analytics? Sure. And I'm sure a lot of people out here are developing shiny apps and such. And those are, I'll give them credit for functional, but they don't look near as nice typically as what someone who does this for a living can make them do. And so from a tactical perspective of getting something up for people to check out for a beta, just to prove it can be done, I think, an analytics person, data science person can pull it off. But if you want to do an enterprise deployment, let's acknowledge that there's design principles that can be followed. There's tricks to making the apps a little more efficient, as well as getting the screens to work on various types of devices. Leave it to an expert. And so what this is someone who comes from maybe a software development or engineering background who also understands analytics, who's able to make that translation. So it's back to needing to have a little bit of both of those on both ends. So yet another kind of translator on top of data translator. And then we get into this new thing of operations roles. Again, years back, there wasn't really a need for, quote, analytic ops or data science ops or AI ops. And the reason was they weren't in operations. We had processes that were run in batch offline, and our results were ingested. Someone babysat those each time. Well, now we're embedding and automating things like never before. And this was the entire subject of my book, The Analytics Revolution, was about this automating and embedding and scaling of analytical processes. Well, when you do that, you've got to babysit them. And again, this is a very different skill set. I'll admit here, I want nothing to do with trying to tune and optimize a system in more of a system engineering or architecture way. There's people who are really good at that. I'd argue these operations roles are another type of translation. This is a translation from really hardcore systems engineering and optimization and analytics understanding, because the types of processes that we run in analytics, like deep learning, like predictive modeling, will use resources somewhat differently than a lot of other things that happen on a network. And you need someone who can account for that as they attempt to handle the ops component of it. So these ops roles, again, I'd argue is another variation on a translator, but they become critical. And if you just think about the roles I've talked to you so far, you can see why it's almost impossible to imagine one person being able to do all of this. It's just simply not. Which brings us to this idea You know, a lot of companies these days, they've got their chief analytics officer finally, or at least a VP of analytics, someone who's an executive role to lead analytics. Well, here's the challenge. And I live this myself when I was the chief analytics officer at Teradata. You get so sucked into, you know, the strategic components of doing the planning, of fighting for the funding, of making sure that what you were doing was known, that you no longer have the ability as an analytics or data science executive to really get in under the hood of the various methodologies being implemented. Again, doesn't necessarily mean you're not capable, but you simply don't have the time. So what I also recommend is considering borrowing from engineering and IT. This idea of a technical fellow, they might call it in engineering. In IT, there's often a chief technology officer that reports to the chief information officer. The CIO often has a huge organization, you know, deals with the overall big picture, but the chief technology officer is incredibly technical, sometimes has no reports, but handles a lot of the actual work to translate the strategy into how to implement. And again, this chief data scientist, think of it as another translator. That strategic vision of the CAO, they translate from that vision into what will the data science and analytics team actually do day by day to make that vision happen. And this should be a very senior, well-respected person from that team who maybe doesn't want to get into a pure management role, but can keep their hands dirty. And again, this is something in engineering and other technical fields, there's often parallels for this. So I ask everybody to give that a little bit of thought, because again, there's only so much that any one person can handle. And now, one role I haven't talked about, I didn't put on my chart, but I'll talk briefly, is this idea of citizen data science. If we tie a few of these things together, let's face it, that is a role. It is coming at us fast, and we have to adapt to the reality that we're not going to get that genie back in the bottle. But, you know, I've really come around to the idea that democratizing data science, it's not as risky as a lot of people think it is. And you know, to give you an example, a couple of years, geez, everything's a year or two ago now with the year we lost. So probably in the fall of 19, I had someone ask me when I was speaking at a conference on democratizing data science, and he said, you know, Bill, everyone would agree that democratizing business intelligence seems fairly safe and reasonable today, but isn't data science a step too far? And I told him that I thought his premise was flawed for this reason. Today, yes, most people would say democratizing basic report generation and such, using tools, anything from your classic reporting tools to tools like Tableau, et cetera, that's pretty safe today. But that wasn't always the case. When I go back, you go back to early 2000s, when tools like business objects and MicroStrategy and so forth were fairly new, they were very technical to use. There was no discussion about democratizing those. They had hardcore technical people who had to make the reports happen. And so let's take a cooking analogy here. If you go back 100 years and you wanted to bake a cake, that took some skill. You had to get all the raw ingredients, you had to mix it properly. You then had to put it in an oven that might have been coal or wood fired with very little temperature control, and you had to manage to get that cake to come out and be very tasty. Well, by the time I was young, we already had cake mixes. You can go to the store, get a cake mix, you throw in an egg and a little bit of milk, and you mix it, you put it in your perfectly temperature controlled oven for the exact number of minutes that they say, and you're going to have a really, really, really solid cake. That's kind of like the BI, right? That's safe. No one's going to say we can't democratize cake making and similar to BI. But let's think about gourmet cooking. That's kind of the data science of cooking. People would say there's no way we're going to democratize gourmet meals. You need a lot of skills. Well, today there are these services that will ship you ready to go gourmet meals. They will have individually portioned out all of the gourmet ingredients. They give you both printed as well as video materials to walk you through it. And you could create a meal that's far better than anything you'd be capable of doing maybe from scratch. Now, will it be as good as what you get from a professional chef? You know, realistically not. You probably don't want to deviate too far, but you can kind of follow the steps that are pre-packaged for you well. This is exactly where democratizing data science is today. There are tools out there now where you can define little widgets that people can connect, and they take an input and an output. And as long as if that person's putting the right input, the output should be fairly reasonable as well. And you can enable folks who aren't quite as technical, who wouldn't be able to do all of the underlying coding, but as long as you put some guardrails around to other people, you can actually pull a lot of it off. So I encourage you all to think about embracing this trend, because it's going to happen. People are always going to find a way. So you either enable them safely or you risk them doing something really bad. So to bring this back then, there's really two dimensions we're talking about specialization. If we think about the classic analytic process, you're defining a problem, you're gathering the data and such, we're specializing across that. But even within those phases, so when you're defining the problem and the approach, you've got your analytic or data translators helping to do the translation. You also have what I'll call the data science generalist, much like your general practitioner in the medical field, who still does the triage and determines what specialists you need to see. These data science generalists at the front end say, okay, this is generally what we need, and we're going to need this type of algorithm, this type of data. Let's parse it out to the right people working with the data translator. When you get into the acquiring and preparing data, data engineers and modern architects who are figuring out how to make the cloud stuff work. Even within data engineering, there's multiple types. I know some that really specialize in streaming and real-time data. Others are specializing in working across on-premise and cloud platforms, et cetera. Obviously, performing and evaluating the analytics, data science specialties, there's all sorts of specialties today. From deep learning for images, natural language processing. There's still people that specialize in forecasting. We've got our analysts, which I'll call the lighter analytics people that focus more on the reporting, the querying, and then the citizen data scientists. And then finally, when you go to deploy, we've got our application interface developers, again, another type of translator going between the modeling world and a application and usage world. Operations people, again, another translator between all of the crazy stuff we need to happen processing wise and keeping the systems doing that so everything works. And then again, the analytic data translators coming in to help the end users understand how to make use of those applications and those results. So with all this, what really keeps up analytics executives at night? And again, I live this, and when I would talk to other executives and we were alone or we're somewhere not being recorded, they'd reluctantly admit how intimidating and scary it was that, when we started our careers, we would literally know what everybody on our teams were doing. You could have, even up in around 2010, I could have still gone in and checked the code of virtually anything anyone on my team was building, if not written the code, because everything was still so simplistic within the platforms that we grew up with. But today, nobody can know all of this. So if you're an analytics executive, are you going to understand DevOps deeply and how cloud architectures work deeply and how AI and natural language processing and how, to build interfaces? The answer is no. And you have to accept that and embrace it and just say, my role is no longer to be the Uber analyst who can do everything my team does. And that's how I got here, kind of like, drill sergeants in the Army who can still get down and show the recruits how to do the push-ups. The role is to be that strategic leader who sets the direction, who wins the support from the organization, and who makes it happen. So executives themselves have to greatly evolve their role if they're going to be successful today, and if the organizations will be successful, and hire the people that understand everything I just went through, trust them to do it, and let it happen. So the key takeaways: acknowledge all this complexity that's here today. Don't fight it. There's nothing we can do to make it go away, but take steps to address it. Accept that you're going to have to rethink many of your traditional roles. Virtually none of the roles you've had traditionally, some of them may maintain, you may maintain a need for it, but you are absolutely going to have to add a bunch of roles, and I think I went through it, multiple of which are variations on translators as well. So start to change that skills mix and how you define your roles within your team today. Back to it, you could start by telling a couple of your really good business-oriented data scientists that you want them to formally focus on doing the translation role for some of the projects. And as you get the momentum, you might eventually put someone full-time, but at least start to change the skills and role mix and take advantage of that athleticism of those members on your team. Look to enable those outside your organization, the citizen data scientist. Get those applications out there to let the business people interface with what you've created more without having to come back to you. That allows you to scale. And then, if you're in those leadership roles, expect that discomfort. You will have to depend on these other people. You will not know what they're all doing, and you're going to have to take their word for it. You won't be able to actually, from your own personal knowledge and experience base, validate that everything that you're being told is, in fact, the very best way to go. You've got to trust your own experts, much like you go into your business partners and ask them to trust you because they don't understand the data science work you're doing. You've got to be willing to eat your own dog food in that sense and do that same trust. And so with that, I'll just say thank you all. My contact information is here. And if there's ever any other questions, you're welcome to reach out. And I think I hit right at my half hour.